Hi, everybody. Thanks for joining the second part of this core workshop. And thanks for being here and being part of this new trend that is going on in the networking realm. So I'm going to talk about enterprise core, or as we subtitle it, SDN WAN done right. Okay. So just a bit of an outline. I'm going to go through the value proposition, the motivation, the architecture and the services, and a little bit of roadmap, the partners that we have, and the results we achieved. So first things first, the value proposition. As Timon and Yen and Oz stressed, also eCore builds on the open platform that is Core. So we leverage the SDN fabric, we leverage the Onos control plane, and XOS as an orchestration. What do we add that is specific to eCore? So we add virtual network as a service with a self-serving portal, zero-touch provisioning, and a combination of broadband and SLA connections. Also, we have integrated analytics that we have in eCore, and we plan to move to aCore, so we can observe, control, and adapt, use the programmable probes, and have on-demand monitoring. Then we also add custom services, especially for enterprises that comprise security, application policy control, WAN acceleration, and stuff like that. But I really want to stress the point that we are not building a custom enterprise solution, but it is just a set of services and a set of Onos applications that live and work in the core platform. So they use Onos, Trellis, XOS, OpenStack, and Docker on top of the leaf-spine fabric. This is not something that we rebuild. We use 90% of what Core is, and then we build our services on top of it. And also important point, we have commodity services, storages, switches, and input-output for the enterprise meter Ethernet. So this is what the virtual network as a service interface looks like. You have multiple sites of your enterprise branches, and you can create, just touching these two sites, a virtual network between them that then goes in and gets deployed in all the fabric and the CPEs on premises and the transport network, and we will take a look at that later. Then we have, as I said, the integrated analytics. This is delay and jitter for your EVC connection, for example. And on top of that, the custom services I was talking about. So SDN WAN today, you have multiple branches of your enterprise and an enterprise HQ, and you want to connect them. You have automated monitoring of multiple network connections, which are mobile, internet, and MPLS-based transport network, for example. And then you have business rules for applications, and you have branch-to-branch traffic optimization. This is what SDN WAN does today. What do we add with Core and Enterprise Core? So we put a Core pod at every branch office. And so every branch office is connected through CPEs to a Core pod. And we keep the automated monitoring, the business rules, and the branch-to-branch traffic optimization. But then, adding Core, we have policy inside the Core pod, and we use commodity hardware and programmable CPEs. We add intelligent edge for low latency, and we have managed services at the edge. As Timon was telling, this is a key point for fast speed. So how does this work? We have multiple Core pods, as I said, here, here, here. We have a transport network in the middle, and we have a metro orchestration on top here that has the service portal, and has the service and network provisioning applications. Here we have both XOS and Onos, but we are also looking, for example, at taking this out and swapping in Onup for that, because we see, as Timon said, Onup as the global orchestrator. And so in our implementation, layer X VPN, layer 2, layer 3 VPN service request arrives, and this gets boiled down in per site layer X VPN configuration. So you have multiple configuration going to each site, and some connectivity policy going to the transport network. And we have a global application in ONOS that is domain agnostic. So it just simply knows that there is something here, and something here that the traffic needs to go through, and maintains an aggregated view of the underlying topology and handles service requests. And instead, in the local, we have just a control over the local topology. So the CPE, the fabric, the transport here, CPE and fabric also here. So how does this work? How can we have this topology in a global unified view that can be leveraged by XOS right now or by Onup in the future? We currently have this notion of the global ONOS, and each piece of the cord pod and the transport network exposes itself as a big switch to the global ONOS through an HTTP channel. So in the current edge topology, we have CPEs and the Ethernet edge switch, and they expose themselves as a big switch with a user network interface and a network-to-network interface. Same here, cord fabric uses it exposes itself as a big switch. Our cord fabric uses OFDPA 3.0 drivers to control the Broadcom chips that we have in there. Same as the transport network. Transport network is built as a set of ROADMs or a single switch, and it exposes itself as a big switch, but there is a change here that we have network-to-network interfaces on both sides. And you see, same HTTP channel, we have an ONOS running here, and we have an ONOS running there, and it exposes itself as a big switch on the global ONOS. I want to touch up a little bit on the transport network, because this is a key part. We have an ONOS-based transport network that is the disaggregated ROADM project and the IP optical project that we currently do at the ONF. And basically, the ONOS-based transport network receives a request from the orchestration layer, and it provides connectivity between cord sites. We have the disaggregated optical network with MEF LSO Presto APIs, but we also have other options, ONF Transport API, but you can also use an existing legacy transport network, for example, an MPLS-based network. And this enables you to not have to change your whole deployment in your whole network. Maybe you just want to try out a single cord pod with enterprise services in a branch and use existing transport network that you have between branches. You don't have to radically change everything, but sure, you can get more optimization if you use the ONOS-based one, because we are able to control the whole set of equipment that runs the traffic. So now that everybody in your multi-topology of cord sites registered itself to the global ONOS, this global ONOS and global orchestrator, in the case of XOS or Onup in the future, has a high-level topology of the pods and the transport network. And they're exposed a big switch, as we said before. Then, what happens is that when an EVC request comes in, the global element does admission controls, it splits it into different forwarding constructs for the different elements that you have in the network, and it does service tag generation. And these forwarding constructs get pushed down to each of the components that we have in our network. So it gets pushed down to the CPE devices and the Ethernet edge and the access. It gets pushed down to the fabric, transport, and then again on the other pod. So let's dive deeper into this. Forwarding construct comes down for the Ethernet edge and CPEs. They do admission control, they do quality of service profile setup, and tagging. And this is the edge topology. And this is done through the CPE and EE drivers. In our reference implementation, we use micro-semi CPEs to do this functionality. Then the global ONOS pushes a forwarding construct to the fabric. And here we do configuration of the segment routing application that controls the leaf spine fabric. We do configuration of the Pseudowire, that is basically a pass-through through the fabric without going into any services. And it basically, we set up forwarding rules for our traffic to hit different services or just go out from the fabric. Then we also have the transport network, and here we do admission control, routing and wavelength assignment, basically to put traffic from one side to the other cord pod. And this was also demonstrated at multiple OFC conferences in the past. So in the local pod, what happens is that at the CPE level, you do push and pop of the service tag, quality of service, and monitoring. The Ethernet edge does policing and QoS, and it does the forwarding to the fabric. And the fabric does cross-connection to the transport network, and basically it does conversion from electric to lambda. On the local pods, these are the enterprise services that we run on each cord pod that gives you connectivity to your enterprises. So we have an enterprise subscriber that comes in through a CPE, and this CPE is on premises at the enterprise. Then the CPE is connected to the VEE that has its own service that abstracts its capability. It can be basically a white box Ethernet switch that does QoS. And then here we do a split of the traffic. This split of the traffic enables us to send your traffic to the enterprise gateway that is something that is very similar to the service gateway in the residential cord. And this goes to the vRouter and then to the public internet. Or if you want something more fast, because it's going to your own enterprise network or your own private cloud, here, you can just use the Pseudowire, cut to the fabric, and go to your other office locations or to your own private cloud as fast as you can to just contact your other branches. And these elements are in the central office of your own cord pod. And instead, here it's to the transport network or the metro transport network. So what does each of these services do? The VCPE does service classification, OAM, and for now it's offloaded to hardware. As I said, micro-semi devices for the access to the enterprise. But in the future, we also plan to have this completely virtualized. The Ethernet edge does QoS, metering queuing, and it differentiates between the public and the private traffic. The VEE is also the one responsible for registering to the global orchestrator, being it XOS or Onup. Then we have the VEG, does DHCP, NATing for internet traffic, and in the future we plan to extend it with firewall specific for enterprises, encryption, which we know it's a key element for enterprises to encrypt their traffic between two branches. And then the Pseudowire, it connects the network-to-network interface and applies the VLAN tag, and it basically provides a pipe through the fabric. That, without going into detail, that is what it's done. At the global level instead, at the global level, we just have one service for now. It's very simple, virtual network as a service. This is the one that provides the pod, multi-branch and pod topology. It's the one that does layer X VPN orchestration. And it's the one that also decides which type of services each pod will run. So this is the chain we provide right now, but in the future, we will provide more services, and the global orchestrator will be the one that decides which services each pod will run. And as Timon said, we currently use XOS for our deployments and proof of concepts and testbed scenarios that we deploy, but we are currently looking at integrating Onup as the global orchestrator. And please, if you have any expertise in this area or have any requirement for Onup integrated with multiple cord pods, we would like to hear your opinion. So you'll see my email later. Send me a message. This is a key element. We're launching a brigade on this. So a little bit of who built this with us. We're part of the core project, obviously, ONF, And as partners, we have China, Unicom, China Mobile, Nokia, and Microsemi, obviously plus everybody else that is currently working on Chord. These are the people that are very specifically targeting eChord. And as I said, Microsemi is providing CPE, Nokia is helping us building services. China Unicom and China Mobile are lab trialing eChord right now, and they plan to deploy it and field trial it in the future. So what are the results we achieved? We demonstrated this at major event, ONS, OFC, Broadband Forum, and now I'm talking to you about it here. We achieved carrier Ethernet service with strong SLAs for you to deploy. We have a big community around it. We also have Argela, who's looking into especially the analytics side of eChord. And also, I want to mention NTT and Telecom Italia that are currently testing and trying out what we are building in eChord. And as I said, China Unicom and China Mobile field trial and deploy eChord around November. And I'm very happy to announce that at Chord Build, we're gonna do a demonstration of the first release of eChord. We call it eChord 1.0. It will be based on Chord 4.0, and it will contain basically everything that I showed to you today. And so let me go a little bit further and discuss the roadmap, because we have a limited number of functionality in what that I showed you today, but we have a lot of ideas on how to bring it forward, and we would like your contribution on this. So we're currently in the process for the release of fully integrating the VNF support and FastPath in the fabric, and having the layer 2 monitoring with OEM and CFM. This is what we're planning to release with 4.1. But then, in the future, as I mentioned multiple times, Onup collaboration and integration, because this goes in the vision of the ONF work and the collaborations with other entities that we're doing. We plan to fully comply with the LSO Presto APIs, especially also automatically generating some of these API with the Yang tools that the Onus project provides, because it's much easier than handcrafting the JSON. Then, currently, right now, I told you that we can do layer 2 VPN provisioning. We plan to expose also layer 3 VPN provisioning through the same set of services, building on top of what we currently have. We also want to do provisioning of VNFs over the wide area network. And also, we want to offload some of the VNFs to the CPEs in order for, as Timon said before, reach that correct point of putting stuff on x86 servers or also on ASIC that does it better for us. So I'm also encouraging you to come in and join our project. We're very open to contribution. Our team is very happy to hear about your use cases and what you plan to do in your own network and how you treat your transport network and what you do with it. And you can, in the future, be here. So a little bit of further reading. And this, I think, I didn't see these slides in before, but I think it is valid for every Chord talk that you see today. We have a website, which is opencore.org. Some tutorial documentation and general reading at wiki.opencore.org, and a guide on how to try out Chord here. Very important part. Some of you are maybe not technical people, but your engineers will be very interested in the fact that this is completely open source. Everything I showed you today, you can get it on GitHub, download it, play with it. Some transport wiki page regarding ONOS. And if you have any question, please do send us an email. I'm Andrea at opennetworking.org, and the leader of the project, Mark Delinea at opennetworking.org. Some of you might know him. For anything, any questions, any thoughts, any further collaboration proposal, drop us an email and we'll sync up. So thanks for listening, and any questions? Yes, please.
Jeff Mansur, a few questions. So you've repeatedly called it SD1. SD1 is per definition overlay service. What you present here looks very much like OSS configured transport services. So it's very focused on underlay. Number two, very often there's no central office at all. It's number of tunnels between locations and server. Could be somewhere in the public cloud. So how does it work in your case?
Yes, so I'm going to try answer this question, and please stop me if I'm going in the wrong direction. So let me go back to one slide. Here. So the idea is that it's true. From this point to this point, it's all transport network. It's layer from 0 to 2, basically, here. But then, here is where you add the services. Here's where you add the monitoring. Here at the level of the cord pod, you can add the SDN, SD-WAN specific elements. This is where we add the SLAs. This is where we add the OAM monitoring. And so I showed you a way to set up a connectivity from here to here, but that connectivity also comprises a set of services that a basic tunneling between two endpoints does not. Did this answer your question?
No, it's done branch TP today. I don't need to go from centralized locations to global service. It's artificial.
Sorry, I didn't get this.
So if you go to any SD1 vendor today, they'll provide you with most probably universal CPE of any kind, and it will deploy on the services and branch on the premise. There's no centralized office location that's grooming all the services.
Okay.
Thanks. So Jeff, the best way to think about this is that it's also possible for us to put push functions into the CPE here, right? You know, and Andrea's not really talking about it that much. So you're right that I think the majority of the SD-WAN market today is CPE-based gear that has multiple WAN links and it routes based on profiles. This is sort of an operator-centric view, and that is kind of deploying it mainly from the CO today. You know, Andrea was starting to get into our ability to push VNFs and functions, service functions out to the CPE and the customer prem. That customer prem could still have multiple WAN links, multiple paths, and help to kind of do application, basically routing at that location as well. But right now, the application routing we do is from the CO back to different transports. And so that's kind of the view of what's available right now.
Sure. And please, to continue this discussion, send us an email. We can further develop on it.
Yeah, it's quite an unusual representation of SD1. But number two, what do you expose northbound? How do you configure more services?
Sorry, come again.
What do you expose northbound of ONUS or platform you've got? How can I configure my service?
Oh, how can you configure your service? So right now, these are the services that, well, these are the services that we support on the local. And you can come in and plug in your service and put it in the service chain of XOS in the local. And on the global side, right now we have the global XOS service virtual network as a service that supports connectivity to create the service. And then if you want your new service to come in, you plug it into XOS or Onup in the future, and that service will expose APIs. If we were talking about XOS exposed APIs, we do have a REST API. We do have a Tosca API that you can configure. For example, our virtual network as a service has a Tosca API where you can define the EVC in Tosca and push it down to the service, and that will set it up for you. This is, I showed you in the first few slides, I showed you the graphical user interface. That's a way to set up for example, the EVC connectivity, but we also have Tosca and REST to do that, because each service in XOS is defined by a model in a language that we call Xproto, and through that language, basically APIs of REST and Tosca get auto-generated. So REST and Tosca is how you configure your service.
Any other questions? Okay. Well, thank you very much, Andrea. Thank you.
Okay.